Yeah, comes on everyone. Let's start off. The last thing we have finished with our kinematics, we'll be starting off with a new chapter, units and dimensions and errors. Chapter is not that difficult, but yeah, it has its own important things. Great, let's start off. Great. Yeah. So, what is this about? So, first thing, we will define a few things there and then we'll go ahead. And this chapter is also useful, when you're trying to guess certain options, it'll actually make your life a little easy. So let's define what is a physical quantity, which we did in vectors. What is a physical quantity? Any quantity that can be observed and measured in an experiment. Right now, these quantities, right, can be classified into three types. Now, like force, mass, time, these things you can measure, these things you can observe. When you classify them, three types. The first thing is fundamental quantities. So what are the fundamental quantities? These are the non-related quantities. Which are used to describe other ones. Example. Now, this is something completely man-made, okay? So there is nothing like a fundamental quantity in the universe. Any quantity could be fundamental. The only condition is they should not be related to each other. For example, mass, length, and time. Now, what do you mean by not related to each other? If you take any two of them, you should not be able to get a third one using the other two. I'll show you an example. Let's say if you take force, velocity, density. If you see, right, these are non-related. You cannot create the third one using any other two. For example, if you have force, mass, and acceleration, F is equal to ma. See, there is a relation between them. So if you can relate these three with an equation, they are related. So these kind of quantities cannot be treated as fundamental quantities. So what is this fundamental? Nothing. So people are just trying to, think of it like, let's create something fundamental quantities to which you can explain everything. Right? So these are like the fundamental stuff. So this is something which we have created. So initially people took, mass, length, and time, and then they realized, was these three things are not just sufficient, to explain everything. So we actually have 7 fundamental quantities. Now, there's all that story there. We'll not get into that. MKS system, CGS, and yeah, all that's nonsense. So not really that important. You can just go through the book or something. Yeah, it's nothing much. It's like when you go to a movie, starting ka jo aata hai na ads, Mukesh ka ad and all. It's like that. It's pointless. Not really useful. But what are these quantities? So the quantity, the SI unit. So we are going to use SI units for everything, and dimensions. So the first thing, when you want to study mass, so you have taken mass as one fundamental quantity. SI unit is kg. The dimension is m. So if you simply say the dimensions of a quantity is m, it is understood you're talking about a mass. Length. The SI unit is meter. The dimensions are L. So the dimension tells you what kind of quantity you're talking with. Time. Seconds are the SI units. So be careful with this. That means every answer that you report in advanced exam or mains exam should be in terms of kg meter per second unless they give something else. If they given the question, the time taken for the body is this, so they're expecting you will mention in seconds. So people thought initially they can handle with these three, but then they realized there are quantities like temperature. This is a thing of its own. The SI units are Kelvin. The symbol is capital K. Then we have current. The SI unit is ampere. And the symbol is A. Then we have amount of substance. Moles. So this is what we use in chemistry. MOL. Then we have luminous intensity. This is for brightness. This you will not see in physics, 11th and 12th. So the first 5 are what we are actually more interested in. Mole, though, you will see in chemistry. Even we will see a little bit of that in thermodynamics, but this candela, CD, this you'll never see anywhere. So the first 3 quantities will deal with mechanics. Kelvin is for thermodynamics. Ampere is for entire electromagnetism. Mole is your chemistry ka thing. Candela is for optics, light and everything. What we are most interested is the first 6. So these 7 are the fundamental quantities. So does that mean you should take always these things only? Not necessary. These are some things which we have chosen for our convenience. You could have actually taken anything else. It would have still worked. The only condition is they should be independent of each other. So as long as you satisfy that condition, everything is fine. Clear with this? So these are the 7 things. Then we have the supplementary quantities. And people realized after this 7, boss, there are still a few more which you cannot explain with these 7. So then we actually created 2 more. So understand this thing. This whole chapter is actually a made up chapter. We did most of the stuff for our convenience. So it works. Plane angle, theta. You know the definition of a plane angle? It's arc length by radius. Is the first thing we did in basic maths. Theta. arc length and radius. So theta is defined as S by R. So if you notice something, it is actually length by length. So the units are radians. So they have units, but it has no dimensions. This is a dimensionless quantity. Meaning mass ka dimension is M, length ka dimension was L. Area ka dimension will be length into breadth. So that is L into L square. So that is the meaning of dimension. So this is a dimensionless quantity. You can have a quantity with units, but no dimensions. Then we define something called solid angle. We will not use this much, but I will show you later on. The things, this is based on 3D thing. So in a sphere, if you take a surface area like this, the shaded area, we did this thing in calculus, the area of a surface area of a sphere, if you remember. Anyone remember? We did something like that. There was an area 2 pi r square 1 minus cos theta. Quite an important result. We'll see that later on. So the shaded area. So here, this solid angle is a 3-dimensional angle, this green one, that circle. So this is given by surface area by r square. The units are steradians. So you can say this is a 3D angle. Theta is your angle in a plane. This is also dimensionless. So in total, we have 7 fundamental quantities and 2 supplementary quantities. Both are angles based. So these are the 9 quantities you need to explain anything in physics. So if they ask you what is force, force is a part of mass and acceleration. What is acceleration? Speed by time. What is speed? Length by second. So you can divide everything into, the basic parts. You can break it down and bring everything to the 7 fundamental quantities and the 2 supplementary quantities. The third one is the derived quantity. So these are the quantities you create from everything else. So these quantities can be expressed in terms of the fundamental quantities. Example, force, energy, power, and so on. Great. Next thing. Angles and the exponents do not have any dimensions. I'll show you what it means. Example, if someone tells you sine of AX. Now, if you see AX is an angle. So this quantity A into X is dimensionless. A can have a dimension, X can have a dimension, but when you multiply both of them, you cannot have a dimension. Right? If someone says tan Z, that Z must be dimensionless. So basically it's a tan of an angle. And just now we saw angles don't have dimensions. Suppose if you have something like e power A, that A must be dimensionless. 10 power B. So A and B are dimensionless. The powers cannot have any dimensions. Think about this. Does this even make sense? 10 power 2 meters is acceptable. That means 100 meters. But what is 10 power 2 meters? Do you get the meaning of this? This is, there's no meaning to this. So 10 to the power of 2 meters is meaningless. 10 square meters is as a meaning. Clear? So when you take sine of an angle, tan of an angle, or e power, or 2 power 3, 4 power 3, that powers will not have any dimensions. So these are the main things: the fundamental quantities, the derived quantities, and the supplementary quantities. Now, the first thing what we will do, now I will give you some quantities. You have to tell me the units and the dimensions. Okay, so let me show you one question and then I'll ask you. They do ask in mains and advanced may also once in a while they do pop up questions, but you do get questions on this. Let me show you one question, what I'm asking you. For example, first thing, if I give you speed. So what you do, right? You choose whatever formula you get. So the one good thing about this chapter, right? This chapter becomes quite easy when the portion gets over. Right? But because by then you'll know all the formulas. But for now, I will give you the formulas whenever required. But later on, you will know. For example, the speed. Take the simplest formula you know. Speed is distance by time. Great. Distance, what is the unit? Meter. Time, what is the unit? Second. So what is the unit? Meter per second. Easy? That's what I'm asking you. What are the dimensions? Meter ka dimension is length. Time ka dimension is t. So you will write this thing as L power 1 and t power minus 1. Those are the dimensions. Understood? When someone says find the dimensions of speed, you have to tell me how many length quantities are there and how many time ka quantities are there. So it is L power 1 and t power minus 1. Yeah, in some books you will see a bracket like this, but that's okay. I'll show you one more. Force. So if I give you a quantity, you have to tell me the units and dimensions. For force, the simplest formula, mass into acceleration. Force ka mass is kg, acceleration is meter per second square. So you can directly write the units. So kg ka dimension is m, meter ka dimension is L, time ka dimension is t square. So this is m power 1, L power 1, t power minus 2. Is that understood, everyone? How to get the units and dimensions? Right? So, great. Now you guys give it a try. Energy, power, pressure. I'll keep giving quantities. You have to keep solving. Get them. Think of whatever formula you know. Give it a try. So what are the units for energy and what are the dimensions of energy? So answer will be in terms of m power something, L power something, t power something like that. Okay, let's see. So for energy, what is the formula? Half mv square. You can take anything, mgh. Anything will work. I'll take half mv square. So mass is kg. See, the number half has no dimension, so that is useless. You can ignore it. Velocity square is meter per second, so that is meter square by second square. So what are the dimensions? Mass, L square, t minus 2. Power is what? Energy by time. So you just take the simplest formula you can think of. Energy we already know, kg, meter square by second square. In that you're putting one more second, so second cube. So this is m, L square, t minus 3. Pressure, force by area. I hope you know that formula from school. Force is already kg meter per second square. Area is meter square. So meter will cancel there. You'll get kg by meter by second square. So this is m, L power minus 1, T power minus 2. Is that clear, everyone? Yeah, you can say Pascal, Watt, Joule. Yeah, those are fine, but yeah. Clear, everyone? Let's see few more. So these are like these formulas you already know. But let's say if I give something of this sort. Gravitational constant. G. This you must have seen in school. I'll give you the formula for you. F is equal to minus G m1 m2 by r square. So like I said, in the final exam, they'll expect you to know the formula. But for now, I'll give you. So F is force, m is mass, r is distance. So right, get that. Next thing, coefficient of viscosity. Now, you need not know exactly what it is, so don't worry about it. The symbol is eta. This is called eta. That looks like some weird n. The formula is F is equal to minus 6 pi r eta v. Again, F is force, r is radius, v is velocity. So you should know the formula. If you don't know the formula, you can't find the dimensions. Angular velocity. The symbol is omega. We call this thing. So omega is angle by time. Yeah, get them. In pressure, this is meter. This is not kg. I kept that in the division. So yeah, get these things. So the headache would be in this thing. You should know the formula. That's it. If you know the formula, these questions are pretty straightforward. So currently, the problem you'll face will be that. Okay, so how do we do this kind of things? So we want to find G, right? So bring G to one side and shift everything that side. So we will get G is equal to minus F r square by m1, m2, right? So what is force ka dimension? Just now we saw force ka dimension is kg meter per second square. So this will be kg meter by second square. That is for force. R square is distance, so that is m square. Mass will be kg in kg square. So simplify this, 1 kg will cancel. So you'll end up with meter cube by kg second square. So the dimensions will be m power minus 1 because kg is in denominator. M is meter, so L power 3. Time is t power minus 2. Got this? You want to find G, get G and shift everything that side. Same thing here. You want to find viscosity. So eta will be minus F by 6 pi RV. So again, what is force ka dimension? Mass into acceleration. Even if you forgot, you can derive it. Mass into acceleration. Acceleration is meter per second square. So kg meter per second square. Radius is 1 by meter. Velocity is 1 by meter per second. 1 meter will cancel, 1 second will cancel. You end up with kg by meter second. So this guy is m power 1, L power minus 1, T power minus 1. Check. Angular velocity is easy. Angle is dimensionless. So that is radian. There is a unit per second, but radian has no dimension, so this is t power minus 1. Clear with this? Any doubts on this? So you just have to get that formula and shift everything that's it, and you're done. All clear? Going ahead. Let's see few more. R, gas constant. This comes from the equation, an ideal gas equation, PV is equal to nRT. P is pressure, V is volume, N is number of moles, R is the gas constant, and T is temperature. Find the dimensions of R. Resistance. Voltage. Magnetic field. So if they give you something which is not done yet, they have to give you the formula. Yeah, but once the portion gets over, they'll not give. But for now, yeah. So for magnetic field, the formula is F is equal to ILB. F is force, I is current, L is length, and B is magnetic field. For resistance and voltage, what will you use? That you know from school. Let's get them. Let's finish all these four. Okay, let's see. So for here, you want to find the gas constant, I think. So R is equal to PV by NT. P is pressure. Pressure is again force by area. Force is again kg meter per second square by area is meter square. So you have to do some work. So we already know this thing, kg meter per second square. Kg meter per second square. V is volume, so that is meter cube, length, breadth, height. N is number of moles, that is MOL, mole, and temperature is Kelvin. So this would be mass L cube T minus 2 mole inverse Kelvin inverse. So they have 5 dimensions there. So this is kg meter cube per second square mole Kelvin. Yeah, that has 5 quantities in one thing. Now for resistance, which formula will we use? If you say V is equal to IR, problem is I don't know what is V. So a better formula would be this. Always try to get a formula from mechanics. Remember power is equal to I square R? Remember that? You learned from school. So power ka formula though we already know. So we know R is equal to power by I square. What is power? Kg meter per second cube. So this one, kg meter square by second cube, and current is 1 by ampere square. So this will be m power 1 L square T minus 3 A power minus 2. Sure with this? So now you have an ampere also there. So every time you won't be MLT only. You'll get amperes, you'll get mole, Kelvin, all this stuff will come popping up. What about voltage? Again, we'll use the same formula, power, voltage into current. So V is equal to power by I. Kg meter square by second cube by 1 by ampere. So this is m power 1 L square T minus 3 ampere power minus 1. Shouldn't that be kg per meter in gas constant? Kg meter power 4, right? Maybe wait. Pressure is what? You're right. That was meter in the denominator. My mistake. This would be meter square. That would be L square. That is fine. That's a mistake I did. So next thing. Yeah. Magnetic field. B is equal to F by IL. Yeah. So force is kg meter by second square. Current is ampere. Length is meter. Meter goes off. M T minus 2 A minus 1. Clear? So this is easy stuff. So this is one type of question they can ask you. This is model 1, you can say. They'll give you a quantity, they'll ask you dimensions. That's the easiest one. The only headache is you should know the formula. If you don't know the formula, you're stuck. All clear with this? The second variety of questions. Alternate fundamental quantities. So if you see this whole chapter, right, units and dimensions, there are like 4 to 5 models. So once you know, okay, these are the 4 types, then it's pretty easy to do the stuff. So after doing all that kinematics, projectile, and all the stuff, this looks like fine. Now, what are these alternate fundamental quantities? Remember in the beginning, I told you mass, length, time is we took, but there is not necessary to take MLT. You can take anything you want. The only condition is they should be independent. We take MLT because I think they look good, right? But think of like this. For example, let's say if you're studying fluids, what makes more sense? Tell me this thing. 1 kg of water, right? Do you like to study water in terms of kg or density? If you take 1 kg of water or 10 kg of water, what remains same? Density, right? So studying liquids in terms of density makes more sense. Getting it? Same way, studying liquids in terms of pressure rather than force makes more sense. So depending on the quantities, right? Sometimes it is preferable to study, quantities in terms of different units. In chemistry, did you study something called electron volt? Did you hear that kind of a term called electron volt? The problem is the energy of this, electrons is so small, converting them into joules is very messy. Did you hear this word AMU, atomic mass unit, in chemistry? This is defined as 1/12 of a carbon mass. That's because these masses are so small, studying them in kgs don't make sense. So every time it's not necessary that, you use MLT. So let's say someone creates this thing. Let force, mass, and velocity be the new fundamental quantities. Someone decided, boss, this should be the fundamental quantities. And we don't like mass, length, and time. They could be, right? Some kind of haters. So be the fundamental quantities. And now you want to define everything in terms of F, M, and V. So let me show you how it is done. And yeah, the question itself is the theory. So let's find the dimensions of time. So you want to find the dimensions of time in terms of force, mass, and velocity. So see, listen how we do this thing. So you're saying time is depending on force, mass, and velocity. Let time be proportional to force power x, mass power y, and velocity power z. You're getting? So till now, did you see what we did? We found m power something, L power something, T power something, right? Now we have to find F power something, M power something, and V power something. You're getting? The same way we did MLT, we'll do FMV. So we will say this time is proportional to F power X, V M power Y, and V power Z. So if you can find X, Y, Z, my job is done. Now on the left hand side, what are time ka dimensions? M power 0, L power 0, and T power 1. On the right hand side, now you go back to your regular dimensions. What is force ka dimension? Force ka dimension, just now we saw, was M, L, T minus 2. So you should know your dimensions. So M, L, T minus 2 whole power X. Mass ka dimensions is M only, M power Y. Velocity ka dimension is L, T minus 1, length per time Z. Then expand this, bring all M's together. That will become M power X plus Y, L power X plus Z, T power minus 2X minus Z. You're getting what I did? I brought all M's together. I brought L together and Z together. On the LHS, we have M power 0, L power 0, T power 1. You can clearly see we can compare the powers. So exponents of the respective dimensions must be same. So left side is M power 0 and the right side they must be same. So exponents of respective quantities must be same. So the mass on the left should balance mass on the right. Therefore, we get simultaneous equation. So first equation, x plus y is 0. So second equation, x plus z is also 0. Third equation, minus 2x minus z is equal to 1. So we can get here x plus z is 0. So from here we can get a z is minus x. So take this and substitute here. So I can just add these two equations. So take this and dump it this. So this will be minus 2 minus z is equal to 1. That would be 2z minus this, z is equal to 1. So if z is equal to 1, then x is equal to minus 1. And then if x is equal to minus 1, y is equal to 1. Yeah, you got everything. Therefore, the time ka dimensions is t is proportional to m power minus 1. No, wait, f power minus 1. So x is minus 1 there. M power y, so that is m power 1 and v power 1. Is that understood how we get this thing? So that means if I use force, mass, and velocity as fundamental, then the time ka dimensions are f power minus 1, m power 1, and v power 1. So if you take some alternate fundamental quantities, this is how you get the relation between the new ones and the old ones. All clear with this? Understood the process? No, I'll give you one. Now give it a try. That is the best way to learn this by giving it a try. If force, I'll take the symbol as F. Density, rho, and velocity, V, are taken as fundamental quantities. Find dimensions of mass. Let's get this. I can give you one more thing. Find dimensions of mass and dimensions of energy. Two different questions. Let's do mass first. So the answer should be F power something, rho power something, V power something. You have to get me those things. Again, remember how to approach this. This is how we start. Mass is proportional to M is proportional to F power X, rho power Y, V power Z, and then you start. Get your force, rho, V in the regular MLT, and then you compare. So you can have a look at this in case you want a reference. Try. It's little lengthy. It's not tough. It is lengthy. So give it a try. Everyone should try. It's solving three simultaneous equations there. So let me show you in case you're still struggling. So you wanted to find a mass, right? So m is proportional to f power x, rho power y, and v power z. On the left-hand side, dimensions will be m power 1, l power 0, and t power 0. What is force ka dimension? Again, I don't know the formula. I always derive. Force is what? Mass into acceleration. Acceleration is meter per second square. So it is m, l, t minus 2. Density is mass by volume. So that is m, l minus 3 whole power y. Velocity, meter per second, l, t minus 1, z. You have to bring back the old MLT ka thing. Now bring all m's together. M power x plus y, L power x minus 3y plus z, t power minus 2x minus z. You get three equations. X plus y is equal to 1, x minus 3y plus z is equal to 0, minus 2x minus z is equal to 0. Now it's just a matter of solving. So what we will do, x is equal to 1 minus y, z is equal to, let's take y actually. Y is equal to 1 minus x, z is equal to minus 2x. So I will eliminate y and z. So I will put both here. So I'll get everything in terms of x. So x will be x only, 3y will be 1 minus x, and z will be minus 2x. That's how you solve simultaneous equation. You just eliminate one variable. So this is x minus 3 plus 3x minus 2x is 0. That's 4x minus 2x. 2x, x is 3 by 2. There we got x is 3 by 2. Once we got x, then we get y is equal to minus half and z is equal to minus 3. Therefore, m is proportional to f to the power of 3 by 2. There it doesn't look that great. Rho is power minus half and v power minus 3. Check. This is how they'll train questions on this. Alternate fundamental quantity. So every time you won't get MLT, they can ask you some weird three quantities and they ask you to find a relation. Clear what we did? Now, can you do it for energy? Try. I'll give you another minute or two. Idea is the same. These are just little lengthy. This is the main theme, and after that, it is brute force. Get it for energy. Any answers? Try, try, try. Everyone should try. If you got an answer, type in the chat box. You can just give me XYZ ka values. Okay. When you do this, the right hand side will actually look the same. I'll do the same thing here. See, I will say energy is proportional to F power X, rho power Y, and V power Z. What is energy? Half mv square. That is m L square T minus 2. Half mv square, right? So that's meter per second. So this is m power 1 L square T power minus 2. So the RHS actually remains same no matter what quantity you bring. Equations will change. So x plus y is 1. X minus 3y plus z is 2. Yeah, this is a little lengthy. Minus 2x minus z is equal to minus 2. Perfect. So y is equal to 1 minus x. Yeah, minus n gets cancelled off. So z is equal to 2 minus 2x. I'll do the same thing. I'll just dump it both here. X minus 3 into 1 minus x to check. Let me know if I mess up any calculations. Z will be 2 minus 2x is equal to 2. 2 will get cancelled. This will be x. 3x, that's 2x. So minus 3 plus 2, so that's minus 1. X is equal to half. Is that right? No, I messed up. I guess we all got 3 by 2. Let me check the calculation again. Mm, minus goes off, so Z will be 2 minus 2x. I'll put it there. So yeah, this looks right. So x 4x minus 2x is 2x. This is minus 3 plus 2. Oh, I already canceled this 2 now. So this is minus 3. This is 3. You're right. Once you got x, then y will be minus half. And then z will be how much? 1 minus half after 1 minus 1. Z is 1, right? Minus half, that is minus 1. Oh, that is 3 by 2. Yeah, what am I doing? Then you're done. So E is proportional to F power 3 by 2, rho power minus half, V power minus 1. Yeah, these are bad. But got this thing? Lengthy, brute force, there's nothing there. This is how you handle them. And the best part about this question, right? There is another way to ask this question, but you'll get the same solution. So we'll talk about that in some time. All clear with this? This is model 2. So model 1 is to get the dimensions. Model 2 is your alternate dimensions. The third type. And this is, if you ask me, it is important. Like when you're trying to guess sometimes, right, in options, especially in CET or bits, right, sometimes you can eliminate options from dimensional analysis. So dimensional analysis is useful to check the correctness of the equation. So this is called as principle of homogeneity. So what this means is you can add or subtract only similar quantities. It's like if I have 3 apples and if I have 2 oranges, nothing happens. You don't get 5, right? They're still separate only. So same way, you can't add energy to force, you can't add mass to time. So only similar quantities. You can multiply and divide different quantities, but when you add or subtract, they have to be same. Only similar quantities can be added or subtracted. That is the whole theme about it. So, example, if someone says energy is given by A plus B into C square, someone gives you like this. That means we can be sure this quantity A and the quantity B into C square should also be energy terms. Because if your LHS is energy, the RHS terms also must be energy. At least the unit should come out to be something like that. The same thing when you see S is UT plus half AT square, you can clearly see this all have same dimensions of length. U into T is dimension of L. So half AT square, UT and S, they all have same, they all are lengths basically. So this is what it says when you add or subtract or LHS and RHS, when you equate quantities, they must be same. But this thing has a problem. There is a drawback. If an equation is dimensionally correct, it does not mean the equation is right. But if the dimensions are wrong, the equations are definitely wrong. So this thing can tell you if it is wrong, but it can't tell you when you're wrong. If the dimensions don't match, so the LHS and the RHS, the dimensions are different, the equation is wrong. But if dimensions match, we are not sure whether it is right. It is like this. If you study sincerely every day, and if you do, if you don't study every day, if you don't do your work, if you don't solve anything, you won't get into IIT. But if you study every day and if you do everything and do all the work, you may get into IIT. It's like that. So if you don't study, you will definitely not get in. If you study, still it depends on a lot more things. So in if dimensions match, we are not sure about the correctness of the equation. Example, if I say S is equal to UT plus 1000 AT square. Now look at this thing, 1000 is a number, right? Dimensions are matching. But this equation is a blunder. We know it is half AT square. That's the problem there. So dimensionally, you can be right, but the equation can be wrong. So if you're dimensionally wrong, then you're wrong. If you're dimensionally correct, you may be right. Clear with this? This is your third model, principle of homogeneity in the dimensional analysis. So exam merit, when they ask you questions, they ask you find the speed of the body. When you look at the options, right, if the dimensions are speed, then it may be right. But if the dimensions are not matching, you can eliminate the option. So let's see a question on this. So let's say U is equal to A square by 2mr square. Remember, numbers don't have dimensions. Bm square by r. U is potential energy. M is mass. R is radius. So this is something we don't know what is the formula. So using this thing, find the dimensions of A and B. This is your model 3. So how do we do this thing? So look at this. So from principle of homogeneity, we know if left side is energy, the right side also must be energy. So if U is energy ka term, then this whole quantity must be also energy. And this whole quantity must be also energy because you can compare only energy ka terms. Great. That means A square by 2mr square must be equal to some energy term. So I'll just call it equal to some energy. That means A is proportional to energy m r square ka root. So I'll just shift everything that side. I can just put the 2 also, doesn't matter. So root over 2 mass r square energy. Okay, na? So you can get the dimensions there. So what is mass ka dimension? So this is root over, mass is m, r is l square, energy is half mv square. So that is m l square t minus 2. So this is A car dimensions. That would be m l square t minus 1. Got this? Same thing we'll do for this also. So B m square by R is also some energy ka term. So then we can write B is equal to R energy by m square. So this would be length energy is again ml square t minus 2 by mass square. I'll do one thing because this dimension will get confused. I'll put a square bracket like this. So that means these are dimensions. Yeah, this would be m power minus 1 L cube t minus 2. Any doubts on this? Sure, how we did this? So you compare. So each term must be dimension of energy term. Let's see one more. Clear, na, Ananya? Dave? Dave, clear with this? Tanmay? Shrikant? Manav? Okay. The next one is a good one. Let's say pressure P is given by A by B e power minus Ct. E is exponential plus C into D sine Bx. This is a weird function. I just made it up. Right? So here T is time and X is length. Find the dimensions of ABCD. You'll never get a function like this. But ठीक है. So pressure is A by B e power minus Ct plus Cd into sine Bx. Okay, let's see. I don't know the answer. Even I need to check. What's the idea there? Go take a break. We'll see this after the break. Come back by 9:45. We'll continue from here. Any doubts so far? Chalo, take a break. Come back in 10 minutes. Yeah, let's see this. So again, the main thing in this question, right? Remember in the beginning, I wrote something. The exponents, the powers cannot have dimensions. So this A by B must be the dimensions of pressure. The C into D also must be pressure because you can add only pressures. And the C into T, so E power something, this quantity must be dimensionless. Similarly, B into X must be dimensionless. So that was the main thing from there. So once you figure that out, so C into T will be, so CT is dimensionless. So C T power 1 must be dimensionless. So M0, L0, T0. So C ka dimensions are T power minus 1. Similarly, B into X, that is L power minus 1. Must be dimensionless. So M0, L0, T0. So B ka dimensions is L minus 1. Once you got that, then you're done. So A by B is pressure. And pressure is nothing but M, force by area. So that is ML minus 1, T minus 2. And B ka dimensions are L minus 1. So therefore A ka dimension is M power 1, L power minus 2, T power minus 2. Making sense? So the main idea is to figure out that CT and BX are dimensionless. Once you got that, everything will fall in place. And then similarly, we'll say C into D is also pressure. D is C is T power minus 1. So dimensions of T will be M power 1, L power minus 1, T power minus 1. Clear with this? This is your model 3. The third type of a question they can frame it on Unity. Others do keep your cams on. The next thing, the fourth type. Dimensional analysis is useful to find the relation between different quantities. In an experiment. So let's say you're doing an experiment and you want to find a relation between them. Yeah, it's not perfect, but at least something is better. So let's take an example. Let's say we have a simple pendulum. So you take a pendulum, the length of the string is L, mass of this thing is M, the mass of the bob, and then we have our gravity G. So when you release it, it will start oscillating front and back. So it will take certain time to complete one oscillation. Now, so you're doing this experiment. And when you see this, you get a feeling, okay, I think if you take a longer string, it will take more time. So it is depending on length. It definitely depends on gravity. And I think it also depends on mass. If I take a heavier bob, so it might go faster and all that. So there are three quantities here, length, mass, and gravity. So we observe the time period, which is the time taken for one oscillation. You're guessing, okay? So this is what happens when you do an experiment and you have no clue. You try to see, okay, these are all the quantities are there, so somehow they must be related. So the time period is time taken for one oscillation. So you're guessing depends on length, mass, and gravity. Okay, that's what you think. Now we want to find a relation between them. So we will start like this. So since it is depending, so time is proportional to L power X, M power Y, and G power Z. Now the best thing is this is exactly like the model 2, alternate fundamental quantities. It looks exactly the same. The solution is same, but there are two different equations. So we use that same method again. So on the left-hand side, we have M power 0, L power 0, T power 1. This is L power X, M power Y. This is L, T minus 2, Z. This is m power y, L power x plus z, and t power minus 2z. M0, L0, T1. You can clearly see y is 0, z is minus half, x is equal to half. That means this time is proportional to L power half, m power 0, and y power minus g power minus half. So if you see this thing, so t is proportional to root over L by g. Interestingly, that means this thing does not depend on the mass. But initially when we saw, we had a feeling it depends on mass. Did you see what happened? You are able to get close to the actual thing. It helps. So when you're doing an experiment and you don't have any idea how they're related, dimension analysis will give you at least some information. In the beginning, there is a strong feeling like it should depend on mass, but it didn't. And the reason is like this in kinematics, we saw, right? If there is no air resistance, mass won't matter. If there's an air resistance, mass would have mattered. So there. So this will help you to get the formula there, but this has a problem. This is not perfect. Uh, the actual formula, if you see, is time period t is equal to 2 pi root over L by g. This is the actual formula. We cannot find the constants. We cannot find that 2 pi. This will only give you the relation, but you cannot tell what is the constants. So these are like the drawbacks. Second thing, if your formula is made of terms adding or subtracting, like ut plus half at square, this method won't work. Because if you look at this method, it is supposed to be multiplication of the numbers, right? And so if you had a formula where you had to add or subtract, this formula goes off. Subtraction of terms, it doesn't work. If you have an equation like PV is equal to nRT, if the formula contains more than 3 fundamental quantities, this thing has 5 fundamental quantities at gas constant, if you remember, mole inverse, temperature, and all that stuff. In total here, there are 5. Yeah, sometimes it doesn't work. So you have a lot of limitations. So it's only for easy things you can do, or else you're gone. So let's see a question on this. Let's say we have a water jet. V is the velocity. So you're sending a water jet with speed V. Rho is the density of the liquid or the water. And A is the area of cross section. And there is a wall in front of it. So this water jet comes and hits the wall and stops. So because of this, there will be a force. Find the relation. between force on the wall let's call it F, and rho AV. So in this experiment, you want to find the force in terms of rho A and V. So what will be the formula? The same question you can ask like this also. If rho A, V are fundamental quantities, find the dimensions of F. The process is same. You have the same solution, but two different questions. So the second model and the fourth model, right, they're kind of identical. The way you're asking is different. Yeah, so let's get this. In case you're wondering, this is how you start. Force is proportional to rho power x, a power y, and v power z. Then you know the story. Get it? Okay, let's see. 1, 1, 2. Yeah, right, Yukti. Right, Karthik. So so F is proportional to rho power x, a power y, and v power z. So force is a mlt minus 2. Mass into acceleration. Density is mass by volume. So ml minus 3 whole power x. Area will be L square y, L t power minus 1 z. M power x, L power minus 3x plus 2y plus z, t power minus z. X is 1, z is 2, minus 3x plus 2y plus z is 1, minus 3 plus 4 plus z is 1. I messed up something. Hmm. Density is mass by volume, area is L square minus 3 plus 4, that's 1. Why am I getting Z0? Yeah, wait, why did I substitute in there? Huh. Y is equal to 1. Yeah. So we get force is equal to rho A B square. Interestingly, the actual formula here is also the same. The actual formula is F is equal to rho A B square. And if you look at this thing, right, if you divide force by area, this becomes pressure. This is rho into V square. Density of water is around 1000 kg per meter cube. Suppose if you take a water jet with a speed of, let's say, 100 meters per second, that's pretty fast. And this value will turn out to be 10 power 3 and 10 power 7 pascals. We will see later on in fluid mechanics, this is almost 100 times atmospheric pressure. So these things, right, are actually used in something called water cutting. Just like you use some, welding, you also have something called water cutting. Normally, what happens with the welding, right? When you try to use heat to cut, the edges will melt. But if you use water cutting, the edges will be pretty sharp. So if you can make the water jet into thin stream, let me show you how it looks. You can even cut metal. This is how it would look. Where are you? So there you can see that that's a thin stream. So you can focus that and you can hit it. And that is a lock, metal one. That it just cuts as if, you have a hot knife and a butter is there and you're just cutting. This is a water cutting. If you put a high pressure beam, you can literally cut through this. Right. So, yeah, so you have to be careful. By chance your finger goes inside, it is gone. There. So it does exert a lot of force. So that rho A V square puts a lot of force. I still remember, I think somewhere in 2014 or 15, long back, in Thane, right, there was a fire. And the fire engines came and they started pouring water, and the building is old. The water jet force was so high, the pillars collapsed and the building fell down. It was a 4-story old building, 4 floors ka thing. So normally movies में देखा था ना, hero comes and catches the fire engine ka pipe and throws water. Bullshit, he will fly away. If you ever seen this fire engine ka thing, 2 people catch that pipe. It exerts so much force. You want to put water to a height of 10th or 15th floor, the speed will be really high. You just can't catch with single hand. But anyway, so that is the fourth model. The fifth one, there are total 5 further units and dimensions. The next one is actually the important thing, significant figures and errors and stuff, but we'll see that. So dimensional analysis is also useful for conversion of units. So let me show you an example. Let's say someone comes and says, like, they're creating a new system, and in their new system, they don't like kgs and stuff, so they did something like this. In a new system, 5 kgs is taken as standard mass. Why should we take 1 kg as standard? If you go to Europe, you will see this thing, right? Foot, pound, and second. They try to study everything in foot and pound. We study in kg, meter. So things do get messed up a lot. I think it's 94 or 78. I don't remember the year, but NASA, right? They launched a satellite to Mars. I think it's Levi Shoemaker or something like that. So they gave the contract to a company called Lockheed Martin. Lockheed Martin is a European company. So the boosters for the satellite, right? They're supposed to be manufactured in Europe. So it went to the Lockheed Martin manufactured it and they delivered it to, the NASA, and NASA people launched it. So these are the boosters for the satellite, this rover, which is supposed to land on Mars. So the regular rockets are NASA only. So they went till Mars. It takes 2 years to go from Earth to Mars on a rocket, right? It takes 2 years. Side pe nahi hai. Not some, Pune or something where you take a local train and go. It takes 2 years. It takes light 15 minutes to travel from Earth to Mars. That means if someone is staying on Mars and you try to do a phone call, let's say you're on Mars and I'm on Earth and I do a phone call, I'll say hi. It takes 15 minutes for you to hear hi. It takes 15 minutes for the signal to reach you. Then you'll say na, hi back again. You'll say, okay, hi. It takes another 15 minutes to come back to the Earth. Means after I said hi, it takes 30 minutes for me to get a hi back. So there is a delay of 30 minutes. In gaming language, this is called ping. If you ever heard about it, latency. Did you ever do a Skype call? You will see there is a lag. Or even when I'm taking the Zoom call, sometimes there is a lag. So that is the time interval difference between the signal I'm sending and the signal you're receiving. On Mars, that lag is 30 minutes. And that's what makes things very difficult. If something happens to the satellite, by the time it sends signal and you receive it, you understand you sent a signal back, it's already half an hour delayed. So you have to predict what happens in half an hour ahead and you have to give signals. Anyway, so they send this rocket to Mars. Normally, when the rocket comes to the Mars, right, it starts orbiting. So you have a main satellite orbiting it. And then from here, they will launch a small rover. So this thing lands onto the planet. So while landing, right, it falls with full velocity. So you need rocket boosters to slow down the speed. And this thing went there. It took 2 years to travel, and then they launched this rover. It started landing on the planet, and it sent a signal back to the NASA, like, boss, okay, I'm landing now, and these are the thrust force and all that data it sent. These people saw the data and were shocked. The amount of force required to slow it down was they're generating only one fourth or one fifth of it. It was actually much less. That means the rover is literally crashing onto the planet. It is not going slow. These people didn't understand what went wrong. They started checking, rechecking, and did everything. And then they noticed this Lockheed Martin, right? They converted all units into foot pound and second, and these people measured everything in kg meter per second. So what these people are thinking 10 is their 10 in FPS, but when you convert this into the normal units, that number is around 4 or 3. So the rockets are actually generating less force than required. By this time, these people realized and sent the signal back. That thing already crashed onto the planet and gone. Just imagine how it feels. You wait for 2 years and it crashes. So happens a lot. And one of the reason, during World War II, Americans hated to fight with, Britons. Matlab, Americans hated this to form a group with, these UK Britain soldiers and fight. Uh, Simple thing. I don't know how true is the story, but there was a company of, Britain soldiers, UK and US soldiers together. They're allies, right? They're fighting Germany and Nazi people, Germany in some African country, Egypt or something. So the Americans, right, said like, okay, Britain people said, okay, we will take care of transport and everything. So we are fine. You just tell me where to go. So this American guy comes and says, we need to travel 500, 500 clicks, so much distance. So put the fuel. I said, okay. And then something happened. So all this convoy was going, and then suddenly in the middle of the desert, right, the convoy stops. And these people go and check what the hell happened, and they realize the fuel got over. Then they start fighting like, why the hell the fuel got over? They said, we did what you said. So these people said, put the fuel for 500 miles. These people kept the fuel for 500 kilometers. Mile is bigger. Mile is 1.6. So that's around 800 kilometers. So these people are stranded in the middle of the desert with the nearest city at 300 kilometers far. So things can go really bad. Anyways, so 5 kgs are taken as a standard mass. units can be really messy. So initially, right, people had this problem. Some guy in Australia is using some units, some guy in India is using Indian units. When people did research, like, it was so confusing. People got pissed off and said, boss, so henceforth, everyone should give only SI units. So tomorrow, when you do PhD, you are supposed to use SI units each and everywhere. You cannot publish in whatever units you want. Anyway, so let's say you created some new system. 5 kgs is taken as standard of mass, 10 meters is taken as standard of length. You are a rebel, so you said 20 seconds is taken as a standard of time. And now we want to find the relation between the force. Let's find the force ka new units and old units. So let's say the initial units were Newton. Now let's call it as Newton dash. So some new force. So in the new system, maybe you didn't like Newton, you started calling it Couton or something like that. So the new units of force are Couton. So how much is 1 Couton in terms of Newton? So something like that. So let me show you this one example, and then I'll ask you one more. We again go back to this. So let's call the new mass is m dash. So m dash is 5 kg. That means this is 5 times the normal m. So this m dash is your new mass, which is 5m. Similarly, L dash is the new length, which is 10L because you took 10 meters. Similarly, T dash is 20T, you took 20 seconds. Therefore, the new force, now remember, no matter how much you change the units, dimensions will remain same. So the new force ka dimensions are M dash, L dash, T dash minus 2. So it will still remain mass length T power minus 2. 1 kg mass or 10 kg mass ka dimensions is M only. But what is M dash? 5M. What is L dash? 10L. What is T dash? 20 T ka square. So this is 50 by 400 MLT minus 2. That means the new units of force, like Couton or whatever I want to call it, this is 1 by 8 times the Newton. So that means the 1 Newton, the new unit, we'll call it Newton dash, is 1/8 of the old Newton. So you can think of like this. That means you can write this thing as 8 times Newton dash is 1 Newton. So just to give an example. So in the old units, if F fold is 10 Newtons, that same 10 Newtons in the new units, you will call this thing as 10 into 1 Newton dash is 8 Newton dash. So this would be 8 Newton dash. That's your new force. Let me give an example. Think of like this. Let's say I have a Cadbury chocolate. In my world, right, one full Cadbury silk is one chocolate, right? That's what I decide. One Dairy Milk silk full thing is one chocolate. What you did, you took this chocolate, you cut it into pieces, and you created 8 pieces. You made this into 8 pieces. According to you, each piece is one chocolate. Making sense? So this is like 1 Newton. This is like your 1 Newton dash. So one old chocolate is 8 times the new chocolate ka pieces, isn't it? Now, if I have 10 Dairy Milk silks, in your frame, how many chocolates you have? Each chocolate becomes 8 pieces and 10 chocolates become 80 pieces now. You're getting? So Newton is like a chocolate. So in my world, chocolate is 1 Dairy Milk silk. But in your world, 1 Dairy Milk silk is 8 chocolates. Now, if I have 10 full Dairy Milk silks, in your frame, how many chocolates you have? You have 18 new chocolates. Making sense? But tell me one thing, did the total amount of chocolate change? Chocolate didn't change. The quantity is still the same. The way you and I are calling is different. Yeah, so just when you get confused in units, think in terms of chocolate. You will remember it really well. Clear with this? So a few more examples on this. If you look at force, 1 Newton is 10 power 5 dyne. So dyne is a CGS unit. So this is an SI unit. Dyne is CGS unit. CGS is centimeter gram per second. I'll send you some theory to read if you want. Like you can just go through all the history and stuff. So similarly, 1 joule is an energy unit. This is 10 power 7 ergs. Erg is a CGS unit. C means centimeter, G means gram, and second. So instead of using kg meter second, someone decided they'll use centimeter, gram, and second. Clear with this? So let's do a question on this. This is your fifth model. So that's the last thing in units and dimensions. Like there is still an errors. That's a different part though. So in a new system, 2 meters is standard for length. T kg is standard for mass. And 5 seconds is the standard for time. And it is given the power in the regular units is 10 watts or 10 W. Find the power in the new units. So in the new units, you have your new unit called watt dash. Again, the chocolate cake example. The first you need to figure out 1 watt will be how many new units, and then we multiply with 10. Give it a try. You can simplify that further. 1250 by 36. I don't think so. You can simplify it. I'm not sure. 0.96. Let's see. So the new unit m dash is 2 times m. Sorry, 3 times m. Mass is 3 kg. L dash is 2L. T dash is 5T. So the new units of power m dash, power is energy by time. So this is ml square T dash power minus 3. Check that formula there. So this is 3m 2L ka square 5T ka cube. That would be 3 into 4 by 125 ml square T minus 3. That's your old unit of power. So the new unit of power is 12 by 125, the old unit of power. That means 1 watt, the new unit, is 12 by 125, the old unit. That means 1 old unit is 125 by 12, 1 new unit. Remember, this is a relation between units. So now your power is what? 10 watts. Replace this 10 into 1250 by 12. Yeah, whatever is that answer. How much is this? 625 by 6. Watt dash. Clear with this? How did you guys get 0.96? Check. Did you guys get the same? This is a relation between units. Huh? Don't directly put the 10 here. All clear with this? Let's do one more. In a new system, alpha kg is taken as standard for mass. Beta meters is taken as standard for length. Gamma second is taken as standard for time. So I'm just giving you some variables. Find relation between new units and old units of energy. Let's finish off. Last one for the day. With that, we'll be done with units and dimensions. So next class, we will do significant figures and errors. Significant figures will be interesting. You will see new max. And there was a question which came in JEE once. It was like this. The length of a cube is 8 centimeters. Find the volume of the cube. That was the question. Length of the cube is 8 centimeters. Find the volume of the cube. And the answer is 500. We will see that in the next class. Let's see how to do this. So what is this? So the new unit m dash is alpha m, L dash is beta L, T dash is gamma T. So the new energy ka unit m dash L dash square T dash minus 2. Substitute here. Alpha m beta square L gamma power minus 2 T power minus 2. Alpha beta square gamma minus 2 energy old unit. So basically the new unit of joule is alpha beta square gamma minus 2, the old unit of joule. Clear with this? That's the relation between them, and you're done. All clear with this? That's about units and dimensions. These are the 5 models you have. The first thing, if someone gives you a quantity, you can find the units and dimensions. The second thing, alternate fundamental quantities. Third thing, principle of homogeneity. You can add only the same type of quantities. Fourth one is in an experiment you can relate them. This is same as the model 2. Fifth one is finding relation between units. ठीक है? ठीक है. With that, we'll wrap up for the day, right? And do remember, there's a test online on Friday, so make sure to give it. It's a good one. We'll catch up on next Monday again. So mostly we should wrap up the chapter in another 1.5 class. And after that, we'll start off with NLM. That's the main topic there in mechanics. Meaning, I would like to call it mother of mechanics. Your NLM is bad, you can forget about mechanics. If you forget about your mechanics, you can forget about physics.